Good day, Sir Ramon Pitao. Our topic is properties of gases. Gases have three characteristic properties. The number one, they are easy to compress. Then the number two, they expand to fill their containers. And the number three, they occupied far more space than the liquids or solids from which they form. So, the first one is the compressibility. An internal combustion engine provides a good example of the ease with which gases can be compressed. So, ang the best nga of good example of compressibility is the combustion engine. In a typical four-stroke engine, the piston is first pulled out of the cylinder to create a partial vacuum. So, ang piston daw ay maong pinakauna na itulak sa cylinder to create a partial vacuum, para makuha sa partial vacuum, which draws a mixture of gasoline vapor and air into a cylinder. So, siyang magmix sa gasoline vapor and that air engine. The piston is then pushed into the cylinder, compressing the gasoline-air mixture to a fraction of its original volume. So, ang piston daw mo magtulak sa cylinder para makompress ang gasoline-air mixture to fraction with original volume. So, the number two is the expandability. Anyone who has walked into a kitchen where bread was baking has experienced that fact that gases expands to fill their containers. As the air in a kitchen becomes filled with wonderful odors, unfortunately the same thing happens when someone breaks open a routine egg and the characteristic odor of hydrogen sulfide H2S rapidly diffuses through the room. Because gases expand to fill their containers, it is safe to assume that the volume of a gas is equal to the volume of its container. So, safe to assume daw na ang gas ay equal o kapareho sa volume sa container. So, the difference between the pressure of a gas and the pressure due to weight. There is an important difference between the pressure of a gas and the other examples of pressure discussed in this section. The pressure exerted by a woman in high heels or a 70,000 pound truck is directional. A truck, for example, exerts all of its pressure on the surface beneath its wheels. The contrast gas pressure is the same in all directions. So, this is the same in all directions. So, gas na directions, kakapareho. So, to demonstrate this, we can fill a glass cylinder with water and rest a glass plate on the top of the cylinder. When we turn the cylinder over, the plate does not fall to the floor because the pressure of the air outside in the cylinder pushing up on the bottom of the plate is larger than the pressure exerted by the water in the cylinder pushing down. So, ang plato daw, ang dili siya matagak katungod kay ang pressure sa gawa sa cylinder ay pasulod ay ginapush to the bottom plate is larger than the pressure exerted by the water of cylinder pushing down on the plate. So mas kuan ng pressure nga i-push ang plate sa kuan. I-push ang plate para di matagak sa floor. It would take a column of water 33.9 feet tall to produce a pressure equivalent to the pressure of the gas in that atmosphere. The discovery of the barometer. In the early 1660s, Galileo argued that suction pumps were able to draw water from a well because of the force of a vacuum inside the pump. After Galileo's death, the Italian mathematician and physician Evangelista Torricelli, 1608 to 1647, proposed another explanation. So, pagkamatay ni Galileo, si Evangelista Torricelli, nagpropose siya og bagong explanation. He suggests that the air in our atmosphere has weight and that the force of the atmosphere pushing down on the surface of the water drives that water into the suction pump when it is evacuated. So, in 1646, Torricelli describes an experiment in which a glass tube about a meter long was sealed at one end, filled with mercury, and then inverted into a dish filled with mercury as shown that the figure below. Some but not all of the mercury drained out of the glass tubes into the dish. Torricelli explained this by assuming that mercury drains from the glass tubes until the force of the column of a mercury pushing down on the inside of the tube exactly balances the force of the atmosphere pushing down on the surface of the liquid outside the tube. So, Torricelli predicted that the height of the mercury column would change from day to day as the pressure of atmospheric change. So, ang height daw ang katason sa mercury column ay magbago adlaw-adlaw as pressure of atmospheric change ang pagbago sa atmosphere. Today, his apparatus is known as a barometer. So, ang iyang apparatus na ginagamit is tinatawag na barometer. From the Greek baros, meaning weight, kabugaton. Because it literally measures the weight of the atmosphere, repeated the experience shown that the average pressure of the atmosphere at sea level is equal to the pressure of a column of mercury 760 millimeter tall. Thus, a standard unit of pressure known as atmosphere was defined as follows. So 1 atm equals to 760 mHg. To recognize Torricelli's contribution, some scientists describe pressure in the units of torr, which are defined as follows: 1 torr is to 1 mmHg.